Well, we've got quite a bit to cover today, and so we are going to be looking at Lesson 2 in Chapter 2, Linear Relations and Functions. So these are the content standards. We're going to be looking about different aspects of functions. Previously, you've analyzed relations and functions. That's what we did in our previous lesson. Today, we're going to identify what linear relations and functions are, and we're going to write linear equations in standard form. We have some new vocabulary, quite a bit today. A linear relation, a non-linear relation, linear equation, a linear function, standard form, y-intercept, x-intercept. Now this is something that's in your textbook on page 69, but it's very important, so I reproduced it here. So we're looking at a linear function. This is a linear equation that's been graphed. Notice it's a straight line. The points on the graph above lie along a straight line. Relations that have straight line graphs are called linear relations. Relations that are not linear are called nonlinear relations. That one's difficult, huh? Now we're looking at the equation x plus y equals 5. That one's called a linear equation. A linear equation has no other operations in it other than addition, subtraction, and multiplication. So notice here we've got addition. And they're multiplication of a variable by a constant. So here this one is multiplied by 1. See, there's nothing in front of it. So that's assumed to be a 1. The variables may not be multiplied together, so you can't have xy. It has to be x plus y or x minus y. Or they cannot appear in a denominator. You cannot have a variable in a denominator. A linear equation does not contain variables with exponents other than 1. So this is x to the first power. If there's nothing up there, that's understood to be to the first power. And the graph of a linear equation is always a line. Now, a linear function is a function with ordered pairs that satisfy a linear equation. Any linear function can be written in the form, and this is read f of x. Remember we talked about slope-intercept form, y is equal to mx plus b? Well, this is simply a function. Function notation is just simply substituting f of x in place of y. So f of x is equal to mx plus b, where m and b are real numbers. Okay, we're good to go. Let's look at what a linear equation looks like. Notice that the only operations are either addition, subtraction, or multiplication. The variables are to the first power. There are no variables in the denominator. And there's no xy or ab, or there's only one variable, and it's got a whole number coefficient. X is equal to 10. These all satisfy those same rules. There's no variable in the denominator. All the variables are to the first power, written as y is equal to mx plus b. You could rewrite this one that way too, right? Subtract x from both sides. You certainly can. This is like plus 0. There's no b there, but you can imagine plus 0. Now let's look at nonlinear equations. This one, the exponent is greater than 1. This one has a square root. That doesn't make it linear. This one, multiplying two variables together. And this one has a variable in the denominator. So you see the difference? If you need to pause for a minute and study those, make sure that you have that understanding. It's very, very important for this lesson. Okay, let's look at example 1. State whether g of x is equal to 2x minus 5 is a linear function. Write yes or no, then explain. Okay, this one is a linear function because it's in the form mx plus b, and m is 2 and b is negative 5. That was pretty simple, huh? Let's look at this one. Is this one a linear function? What's the problem with it? If you told me that x is to the third power, that's the problem, you are exactly right. It has an exponent other than 1. You guys are awesome at this. Okay, let's go on. What about this one? Is it a linear function? It's placed a little differently, but could you move it around so that it would be linear in the form mx plus b? Why, certainly. Just switch them around. The 7 is the m and the 4 is the b. So this one is also a linear function. Okay, check your progress. You did so well with the others. Let's see how you're understanding here. So pause the video for a moment and then answer. Oh, yes. This one's in the form mx plus b. 3 is m, negative 2 is b. Good job. Let's try another one. Is x squared minus 4 a linear function? Pause for a moment. No, has an exponent other than 1. So good. It sort of fooled you. M could look like 1, but it's x squared, so that throws it out. How about this one? No, two variables are multiplied together, so that one doesn't work for that reason. We've got x times y here. Good job. Okay, let's move forward. Pause for just a moment and read this problem. Okay, then we double check. What is it they're wanting us to find out? On the Celsius scale, normal body temperature is 37 degrees. What is it in degrees Fahrenheit? Well, this is going to be simple substitution. We've got f of c is equal to 1 8/10 c plus 32. We're wanting to know what it's going to be like if it's 37 degrees Celsius. So c is 37, and we simply solve 98.6. That's the normal body temperature in degrees Fahrenheit, 98.6. Okay, let's build on that. Now they're asking us, there are 100 Celsius degrees between the freezing and boiling points of water and 180 degrees Fahrenheit between these 2 points. How many Fahrenheit degrees equal 1 Celsius degree? Well, we're going to divide the 180 Fahrenheit degrees by 100 Celsius degrees. So the answer is 1.8 degrees Fahrenheit. Okay, check your progress. We're given this function. We're asked, if you hear thunder 10 seconds after seeing lightning, how far away is the storm? So pause for a moment and work this one. Okay, so 10 seconds. So in place of s, we're going to plug in a 10. 1/5 times 10, or it'll be 1 times 10 divided by 5. That gives us our 2 miles. Okay, good job. Let's do another one. Now, if the storm is 3 miles away, how long will it take to hear thunder after seeing lightning? Okay, here they're wanting us to find the seconds. So 3 miles is equal to 1/5 seconds. So in order to get rid of the 1/5, we've got to multiply both sides by 5 because we're solving for s. So that means 15 seconds. Here's another key concept. Here we're going to learn about how to write the standard form of a linear equation. So we've been manipulating equations all this time so that y is equal to mx plus b. Now we're going to write it so that ax, or some number x plus whatever y is equal to the constant. This is what it'll look like. If a will be 3, b is 5, c is 12. So if you need to pause for a moment and study that, that's great. We'll move on when you're ready. Okay, so they want us to write y is equal to 3x minus 9 in standard form and identify a, b, and c. So the first thing we need to do is put the x first, then the y, and then the constant all by itself. So we're going to subtract 3x from both sides. That way we have it as ax plus by is equal to c. Ax plus by is equal to c. So stop and think a minute. What is a? What is b? What is c? We're also going to multiply each side by -1 because a has to be greater than 0. It can't be a negative number. I almost forgot about that. Okay, so a is 3, b is -1, and c is 9. We good to go? Let's try it on this one. So pause for a moment and manipulate this so it's in standard form, and then tell me what would it look like. Sure, we're going to add 2x to both sides. So 2x plus y is equal to 5. Awesome. Okay, now we're going to find the x-intercept and the y-intercept. So simply, x-intercept is where it crosses the x-axis, and the y-intercept is simply where it crosses the y-axis on the graph. So we're given this equation, negative 2x plus y minus 4 is equal to 0, and we're going to graph the equation. So how do we go about doing that? Well, the x-intercept is the value of x when y is equal to 0. So in essence, we're going to put a 0 here for y to get rid of it so we can find out and solve for x. That's sort of eliminating a variable, right? So in place of y, we're putting a 0, and then now we're going to solve. We add 4 to both sides, so we have negative 2x equal to 4. So x is equal to negative 2. So when y is 0, x is 2. So we can rewrite that as negative 2, 0. So we know that the graph is going to cross this x-axis at negative 2, 0. Now we need to find the y-intercept. So where does it cross y? Well, how about if we make x 0, then we can solve for y. That's all we have to do. So y minus 4 is equal to 0. Add 4 to each side, so y is 4. So the y-intercept is 4, or it crosses the y-axis at 0, 4. Very good. Now we're going to use those two ordered pairs, negative 2, 0, and 0, 4, and we're going to graph those 2 points, and then we can graph the equation. So we can not only graph from slope-intercept form, but now we've learned how to graph using standard form, just substituting in zeros so we can see where it crosses. So check your progress. What are the x-intercept and the y-intercept of the graph 3x minus y plus 6? Okay, if we put a 0 in for y, we'll have 3x plus 6 equals 0. Subtract 6 from both sides. Divide both sides by 3 so that it crosses the x at negative 2. Now if we put a 0 in for x, we've got negative y plus 6. So y is equal to a positive 6. Okay, excellent. Good job. Now you're ready to begin the work on the examples.